Can you hear me now?
Yeah.
Okay, thank you. Okay, we'll start from the beginning. Sorry. I told you I'm not so technology inclined. Okay, let me see what I can do now. Okay, let's start from the beginning. Okay, I said today we're working on, okay, let me say good morning first, now that nobody could hear me. Good morning, everyone. Welcome to the class. So today we're going to look at normal distribution and its application. So I said, what you look for when you have questions for normal distribution? Number one, you look for the word normally distributed or as a normal distribution. Those are words that play around. Number two, you look for your mean. Is it either written as mean or expected value? Number three, you look for your standard deviation, or you could be given a variance. And number four, you decide what you've been asked to do in the question. So let's look at the first example. From our lecture notes, it says the time it takes to finish a standard entrance exam is normally distributed with a mean of 60 minutes and a standard deviation of 8 minutes. What is the probability that a student will finish the exam in between 60 and 70 minutes? So you see the word dancing around, which is normally distributed. That's the word, that's your key word. Number two, you see your mean, which is given as 60. So your mean,
Ma'am?
yeah?
Which page of the lecture notes?
Page 2, did I share? I'm not sure if I shared this with you. It's week 4. Yeah, continuous probability week 4. Do you have that on the lecture notes?
What page?
Page 2. It has slides on the page.
Oh, okay.
Yeah, the one it has
Okay.
calculating normal probabilities on that page 2. Then it has solution and next to the, so the one that has calculating normal probabilities is the example we're doing.
Okay, thank you.
Okay, you're welcome. So we have a mean as 60. We have a standard deviation as 8. In this case, that's a sigma. Our mean is a mu. We're asked to calculate probability of x is between 60 and 70. So that's what we're asked to calculate. Our formula is z equals to x minus mu over sigma for standardizing. So when x is 60, z equals to 60 minus our mu, which is 60, over sigma, which is 8. That gives 0 over 8, and that gives 0. When x is 70, our z is 70 minus 60 over 8. That gives 10 over 8, and that gives 1.25. Is this clear up to this point? Any question? Now, having calculated our z's, we go to the table. The table I gave you on Monday, the standard normal distribution table. We check for when z is 0. When z is 0, our value is 0. From table, we get 0.0000. When z is 1.25, from table 1.25, that's 1.2 under 0.05, and that gives us 0.3944. Is this okay up to this point? Next, we need to determine, because it's from one point to another. So let me just clean up this space, then we can draw our graph. So our graph should look something like this. Our mean is at 60. This is at 60, middle point. Our 70 should be somewhere here. At 60, so we're looking for this area. This shaded area is what we're looking for. Okay. At 60, it says the area is 0.000, 0.000. And at 1.25, which is 70, it is 0.3944. So 0.3944 is definitely from this point to this point. So our area is from 0 to 0.3944. So probability that 60 is less than x is less than 70 is the same thing as probability. Now when we calculated, we got 0 for 60 is less than z, because now it's z, and is less than 1.25 that we calculated. So you see the languages are changing, equals to 0.3944. If you're going to, that's our answer, bless you. If you're going to interpret this, you can write it as this and equals to 0.3944. Or interpreting, you can say there is a 39.44% chance that the student will finish the exam between 60 and 70 minutes. There is a 39.44% chance that a student taking will finish between 60 and 70 minutes. Any question, please? So it's well understood. Okay. Let's look at example 2. Example 2 says, determine the following probabilities. Probability that Z is greater than 1.47. So we need to go to our table. Now you see the word Z. That means your Z has been calculated, and when it was calculated, it's 1.47. So from table, (1.4) under 0.07 will give us 0.4292. So let's try and draw our graph. This is the middle. This is probably 1.47. We're looking at the probability that it's greater than 1.47. So is this shaded area we're looking at? Now this is 0.47, 0.4292 from the table. If this is 1.47 and this is 0.4292, it's most likely that from here, the middle point to this place is 0.4292. Is that okay? We already know that this area is 0.5. So what would this shaded area be? From this middle area to this end area is 0.5, but we already have from here to here. So we need from here to here, which we call, let's say, A. So A will be 0.5 minus 0.4292, and that gives us 0.0708. So probability that Z is greater than 1.47 equals to 0.0708. Is this well understood?
So, ma'am,
Yeah?
you didn't use the formula because it's right?
Because you already calculated. Can you see what is written here? It's a Z, not an X.
Oh, okay.
So you have to be careful. If it was an X, then we calculate. But when you see a Z, that means it's already been standardized. That means they've used the formula Z equals to X minus mu over sigma. And when they used that formula, this was what they got, 1.47. So you have to go to the table, check your equivalent value at 1.4 under 0.07. That was why we got 0.4292. Then you draw your graph to see where you stand. This is 1.47, and we need area greater than, which is this shaded area. But from the table, we got 0.4292. So definitely the area from this table is from this middle point, 0. Remember we said the graph is symmetrical. So half of this is 0.5, half of this is 0.5. So the middle point is your mean, and that is where it divides into 2. So definitely from this point to this point is the 0.4292. So you need this area. So all you have to do, since this area to the end is 0.5, subtract 0.4292 from 0.5, then you get this shaded area. And that's your probability of Z greater than 1.47. So you have to be careful. When you're giving probability of X, then you have to standardize first. But when you're giving probability of Z, that means it's been standardized already. You have to just go to the table. Is that okay? There's probability of a negative number. Just to show you that it's possible to calculate, we have probability minus 2.25 is less than Z, is less than 1.85. Now we go to the table first. You see Z. So that means it's already been standardized for you. We go to the table. We'll first of all try and get 2.2 under 0.05. 2.2 under 0.05. That gives us 0.4878. And then we also check 1.8 under 0.05. That gives us 0.4678. So let's see how we're going to apply this. This is a trick. Let's draw our graph. This is the middle. You remember we said when you standardize, it has a mean of 0 and a standard deviation of 1. So this is our middle at 0. Because we have a negative number, minus 2.25, we're going to pretend that this is the origin. Everything to the right is positive, everything to the left is negative. So we're going to mark our 1.85 on the right of this 0. We're going to mark our minus 2.25 Because it's minus, it's going to be on the left-hand side. So what we need is this area in between. Now, how do we know this area? 2.25 from the table gives us 0.4878. Remember, from this middle area to this end is 0.5. So most likely our 0.4878 is from this middle area to this point. Do you agree with me? So this is 0.4878. Just this area to this area. From this area to 1.85, this area is 0.678, because from here to this end is 0.5. So this area is 0.4678. So our total area (0.4878) plus 0.4678. Is 0.9556. So probability of minus 2.25 is less than Z, is less than 1.85 equals to 0.9556. Or you can say there is a 95.56 chance that as Z lies between minus 2.25 and 1.85. Okay. Any question, please? Okay. We're looking at probability that 0.6 is less than is less than Z, is less than 1.36. From the table, what do you get for your 0.65?
You get 0.2422.
Okay, thank you. Is that Kerry or Rowan?
Runwin.
Rowan, how are you?
Good, and you?
I'm fine, thank you. Okay. Thanks. And 1.36 from the table.
It's 0.4131.
Okay, thank you. 0.4131. So we've gotten that from the table. Let's draw to see what is happening. It's always good to draw. This is 0 at the middle. This is 0.65. This is 1.36. So what we need is just this area. Okay, that's what we need. Now, 0.2422 is definitely from here to this place, isn't it? From this point to this point, which we'll label as A, is our 0.2422. 0.4131 is for 1.36, so it's from this point to this point, which we label as B. What we need is our C. So how do we get C? B equals to A plus C. We can see from the figure. Therefore, C equals to B minus A. Our B in this case is 0.4131. Our A in this case is 0.2422. If you subtract, that gives us 0.1709. So our answer in this case is 0.1709. Is that well understood? I can't see Wemby. I'm trying to see if I can see your faces, all of you. Luyando, I can't see your face. It's not showing. Oh, okay, I can see. Can see Wemby's face now. So we're all on the same page now. Everybody happy with normal distribution? Okay. Is there any other example? Okay, there are more examples. It's not too bad to try. The rate of return X on an investment is normally distributed. So we see our friend again showing face. Normally distributed with a mean of 30% and a standard deviation of 10%. What is the probability that the return will exceed 55%? So we're looking at probability that X, we're looking at probability that X will exceed, that means greater than 55. That's what we're looking at. So in this case, our mu is 30%, our sigma is 10%, z equals x minus mu over sigma. Our x is 55, that's what we're looking for, minus 30 over 10. Which is simply probability that z is greater than 2.5. What is probability z? What is 2.5 from the table? $2.5 from the table, what do you get?
0.4798.
Okay, 0.4798. Okay, so let's see what our table graph should look like. Thank you. Our middle part is 30, at 30, which is our mean. We're looking at greater than 55. So we're looking at this shaded area. So definitely 0.478 is from this middle area to here. But we know that from this area to this end is 0.5. So this shaded area will be 0.5 minus 0.4798. And that should give us 0.0202.
Ma'am, I think that figure is wrong from the table. I think it's supposed to be 0.49379.
2.5. What did you get? Where did you get? It's 0.49379.
I think Ronwin just got it wrong. She went 2.05, not 2.5.
Oh, okay.
That's where she got it
Thanks.
from.
Okay.
Cool.
Okay, let's rub this off so we don't get the wrong answer. So from the table is 0.49379. So this area is 0.49379. 0.49379. And that gives 0.006. 621. Yeah. Are we cool with that? Now we're looking at probability that the return will be less than 22. Less than 22. Put a 22 here, you get a minus 8. Get minus 0.8. Z is less than minus 0.8. From table, zero point 0.8 should give you 0.2881. So let's draw our graph. This is 30 here. So your 22 should be somewhere here. We're looking at less than 22. This is shaded area. Zero point 0.2881 means that it's from this point to this point. Do you all agree with me? From 30 to 22, from the table we get 0.2881. Do you all agree that it is from 30 to 22? Do you all agree? Nobody's answering me. So this is A. What we need is B. So B equals to 0.5 minus A. Since this area is 0.5, minus 0.5 minus 0.2881, and that gives us 0.2119. Now we're looking at two more examples before we move forward. The first one is that you're asked to determine Z subscript 0.025. Subscript. What this means is that if you draw your graph, this is our central point. This part, this area, is 0.025. It could also have a mirror image, 0.025. So this unshaded area from this middle will be 0.5. Let's call this A. Let's call this B. So 0.5 minus 0.025 equals to A. And in this case, we get 0.475. So this is 0.475. 0.475. So what do? You can see that it's subscript. So you go to your table, you go and look for 0.475, where it is, where that figure shows on your table. If you look at 2.0 under 0.00, you get 0.47772, which is more. So you have to decrease. If you check 1.9 under 0.05, you get 0.4744 on your table. So what you should look like, the next one is 0.4750, which is exactly what we need. If you check, it is where 1.9 intersects with 0.06.
May you repeat that? Which number are we looking for on the table?
0.475. You're looking for that number, not at where it meets, but in this body. All these numbers, small numbers you have. That's because you add Z subscript 0.025.
Okay, thank you.
So what that means is that you must chunk out the area of 0.025 and find out that what is the rest of the body. The rest of the body is 0.475. So you go look for that 0.475 from the chunk area of all these figures you're looking at. So if you look at it, you find out that 0.475 is where 1.9 intersects with 0.06. So that's 1.9 intersecting with 0.06 to give us 1.96. So Z 0.025 equals to 1.96. We're asked if Z is a standard normal variable, determine the value of Z for which probability of Z is less than small z equals to bracket 0.6331. So we're going to look for 0.6331. If you look at your table, you can never get 0.6331 from your table. It's impossible. So what does this mean? What this means is that if you draw your graph, the best you can get is 0.5, which is 0. This is 0. What this means is that the area from one point to the other is 0.6331. So from this point to, since this area is 0.5, that means 0.6331 must be greater than that area. So let's put this at 0. So this area is 0.6331. So we need what this is. We already know that from this point to this point will be 0.6331 minus 0.5, and that gives you us 0.1331. So we go check on our table for 0.1331 out of all these figures. Oh, 0.1331 is 0.3, where 0.3 and 0.04 intersect, and that gives us 0.34. So our Z here, small z, is 0.34. Any question, please? Okay, let's just look at one on. Okay. Given that X follows a normal distribution, Given that X follows a normal distribution, with mean 64, and standard deviation 0.5. Obtain 1, probability X is less than 63. 2, probability that X is greater than 63.7. Number 3, probability that 62.9 is less than X is less than 64.3. Number 4, probability that X is greater than what equals to 0.1026. Okay, let's try this. I need to get myself a drink. Please excuse me. Okay. What did we get for the first answer? Sorry, I'm back. Have you all gotten the answers? What did we get for the first answer?
The final answer?
Yeah.
I got 0.0228.
0.1
2.
228. Let's see if we got that right. Did anybody get
No,
the
0.
same? 0.028.
0.0228.
0.0228. Did anybody get an answer different from that? Just so that I'm trying to get my calculator. What is mean? So 1 divided by 0.5. That gives us 2. Okay, so our mean is 64 and standard deviation is 0.5. So the first one will be 63 minus 64. Divided by 0.5, that will give us minus 2. If you check your table, 2.0 will give us 0.4772. We're looking at probability of it being less than 63. 0, 2, less than. Minus 0.4772. Okay, so it's 0.0228. So we all agree with that. Second one, what did you get?
I got 0.7257.
0.7257. Okay. Did anybody get anything different? .6. So we're looking at probability that it's greater than 65 is here. Sorry, what did you say you got? 6. Okay.
Oh, I got 0.7257.
Okay, I just want to see 0.2257. Yeah. Yeah, you got it right. Third one. Anybody got something different? Okay. Okay, number 3. Nobody is saying anything.
For 3, I got 0.7118.
3 point
0.7118.
0.7118. That was all you got.
Yeah.
Did anybody get a different answer? Okay, we all got the same. Last one.
Is that answer right?
Yeah. Last one.
For the last one, I got 64.52.
Okay, let me check. 1426. 0.1026 is 0.2 0.26 64.5 What did you say you got? 0.64.6. Okay, let's see now. I hope I'm not doing the right. 0.26. Let me check my table very well. 0.26. 0.26, yeah. Times 0.5. I got 64.13.
Would you take us through it?
Okay. Let me just be sure. Just hold on. Let me work backwards. Minus 64 divided by 0.5. 0.26. Okay. It says probability of x equal to what? Gives you 0.1026. So you go to your table and look for where you have 0.1026 from the body of the table. Check the body of the table. And when you check, you find out that you have 0.1026 at 0.2 intersecting 0.06, and that gives you 0.26. Yeah.
Mm-hmm.
So you have 0.26. So what this means is that I need to note this up. What this means is that because it's x, not z, that means your x minus your mu, which is 64, divided by your standard deviation, gave you 0.26. So cross multiply. X is that okay? Okay. Are we all happy with this?
Yes.
Okay, thank you. Sorry, I have another class at 12 o'clock. So I have to schedule the meeting now and jump on another class. So on Monday, please, we'll look at, before the practical, we'll still be at PC Lab 6 for 2 o'clock. We'll be looking at central limit theorem. We'll look at confidence interval. And we start hypothesis testing, looking at contingency table. And then we can do the practicals for that day. Any question, please? No question? Thank you all for coming. Have a lovely weekend. See you on Monday. Thanks. Bye.
Thank you.
You're welcome. Bye.